Hello, everybody. Thanks for having me. This is such an exciting lineup to be involved with. So many cool updates coming out from the FDM and Lurk, like really awesome. And Textile's been watching a lot of this very closely and trying to think, what can we do in this space to really help move this forward? And so today's talk is called What's Under the Bridge. Some of you may be wondering what bridge we're talking about, and so I wanted to give that to you just up front because I'm going to go on a little journey along a different path to start. So you can find more about the bridge at eth.storage. I'm also going to talk about a concept we've been building that hopefully will lend itself to a lot of what's coming into VM in the near future, called Filecoin deal auctions, and you can find more about that at this tiny URL. I'll get back to those at the end. But I want to talk about the bigger picture first. Why are we talking about all of this? And for me, the bigger picture really is important because it drives all of Textile's vision and mission and really helps us figure out what we want to be building and who we want to be helping with technology. So I want to start with a little story that I think many people watching probably are familiar with the first part of it. But let's start with Kardashev's scale. So in 1964, Kardashev came up with this idea that we could describe the progress of civilizations in the universe by the amount of energy that they were able to harness. And so he initially just had three types of civilizations: a type 1 civilization that's able to harness all the energy that arrives at its host planet. A type 2 civilization is able to harvest all the energy that is emitted from its host star. And a type 3 civilization is one that can harness all the energy of an entire galaxy. And you can see there's something like a billion orders of magnitude between just the last two. So these scales are huge. Unfortunately, humans aren't even on this scale. There's no type 0 in the initial scale, and we don't harness all the energy of our entire planet yet. So that's interesting, but I think even more interesting is an idea that Carl Sagan came up with, as were most of his ideas. But he said there's another criterion that we could measure civilizations by, and that's the amount of information that they store. And I think what he really meant by store here is have access to. And he said that information could just be described in terms of bits. Or if you're not familiar with how to think in bits, simply a number of yes-no statements that we can use to describe and classify the universe that we know. Okay, so what does it mean to know information? We need to unpack this a little bit so we can arrive at how do we use that to classify and understand the progress of civilization. So what does it mean to really know information? And I think using that yes-no framework really helps here. And so he said store, meaning access to. So knowing information means having access to it. And if we think of it as a series of yes-no questions, we can use the game of 20 questions to frame this and look at how much information we have. So in case you're not familiar, which I'm sure all of you are, a game of 20 questions is just one person has a thing that they think of, and the other people playing have just 20 questions that all have to have a yes-no answer that they need to use those 20 questions to arrive at what that thing is. So let's see it in action, because what's really interesting is that each question that you ask divides the universe into two portions, 2 bits. And so as an example, we have this universe of things, and I imagine a thing. Now you want to get to what that thing is. So you ask, is that thing an object? So in that first question, you've created the first bit. Then you might ask, is it biological? If my answer is yes, you move down another path, but you've divided the universe again. And so in just 3 questions, you've divided the universe into 8 possible outcomes. So 8 bits of information. So in 3 questions of 3 yes/no questions, we've created an 8-bit universe. So in the game of 20 questions, so it's 2 to the 20, so just over a million bits of information, and we love base 10, so something like 10 to the 6, roughly. So Carl Sagan said, okay, that's a great starting place to measure the progress of a civilization, 10 to the 6. And he said, let's build a scale from that. Let's start there and say, every time we move up the scale, we'll describe a more advanced civilization on the information scale. So type A civilization, he said, had 10 to the 6 bits of information accessible to it. And then moving up, he arrived at the type H civilization with 10 to the 14 bits. his estimate of how much information 1970s humans had available to them. A more recent estimate on this scale says that humans in 2018 were a type J civilization. And so if we multiply that by 1 million, we get to the type Q civilization. So this would be a galactic civilization with the information of 1 million worlds like our own. And so this goes all the way up to type Z, which is something that Carl Sagan posited wouldn't even be possible given the age of the universe yet. But this is really cool. So humans are currently type J civilization. Like working in kind of the startup world, I think, oh, that's so interesting. That's the KPI for humanity. That's the KPI for us as a civilization, is we can track humanity's progress by looking at how much information we have access to. What I think is really interesting when you look at it that way is something's holding us back. And I know something's holding us back, but I don't have a lot that I can show you, but I can give you the same feeling. And that's why I'm telling you this story. So my feeling is that there's something odd going on right now between the information that we create as a civilization and the information we have access to, the key to moving across the scale. So as time has moved forward, our creation of information has really gone exponential, but our access to information has trailed behind that. And that information gap, I think, is what is leading to a lot of uneasiness, especially in technologists today. We're in this period of runaway information creation. So if you think of early days of networks, of computer networks and emails and message creation, that information creation just in your personal life has run away. So it moved to shopping and clicks and behaviors online, your photos. Now you're dating, and your friendships and your relationship preferences and your location and your medical records. And that data is just going up and up and up and up. But the internet economy is fueled by privileged access to that information. And that sort of discrepancy between who is collecting the data and who has access to it is leading to a gap, leading to that information gap. Oh, sorry, I lost an image here. And what's even more interesting there is that discrepancy is snowballing on itself. And so some people have said data has network effects. And the reason that is that as an organization or a government collects more data, they actually are able to gain further insights from it and feed it back in to collecting more data. And so in a sense, data has gravity. The bigger it gets, the more mass it gets, the more gravity it has to collect more data. And we see that even with the creation of data silos in organizations. We see companies be bought entirely for their assets of data. So these closed silos that we're creating in society may be among the most valuable things ever created. And so this fact that data has gravity means that they're going to continue to grow, they're going to continue to become more valuable, and it's very hard to get that back into society's hands. What I think is actually important to point out here, though, is that this collection and organization of data may actually have been a good thing for society over a short period of time. It's led to a number of great innovations in technology, but over a long period of time, this could be very bad. And this could be very bad if we think about our progress through the scales of civilization. And so I'm sorry, Carl, we might be stuck for a while if we're not careful. We may not move as fast through these scales as we would hope to. So how can we fix this? Well, I'm a big believer that one of the first ways that we fix it is with storage. And that's why we're so excited about Filecoin, is it starts with access, it starts with preservation. And decentralized storage offers us the hope that information can truly be made free to all of society. So I can store scientific information that anybody in any country, in any school, in anywhere can access and use to create more information for us as a civilization. So storage and linked data for me are very important. And then it goes to access and collaboration. And so Textile, our mission is to increase the exchange of information across society. This is very intentional wording. Exchange is bidirectional, implies value, it has multi-actors, it has permissions. We think this is actually something that we can measure as a company. We can measure our impact here. And it starts with actually just looking at how much data we can move across peers in the networks that we create. So this brings me back to the point of the talk, what's under the bridge? So I want to show you some concrete pieces that we've been working on and experimenting with that are moving us towards this greater exchange of information for society. What we're imagining is high throughput storage protocols for communities. So rapid I/O, indexing, curation, and compute all on top of Filecoin. If you heard Raul's talk or just the previous talk, these ideas of FVM on Filecoin, they're so exciting for us. And this is what we're building towards. We're building towards the next layer that sits right on top of that and adds the abstractions so that society can build new data silos that are owned by communities and support the needs of DAOs, of games, of networks of creators, of researchers, and more. Let's look at some of the things that we've already built. So one of the experiments that we're doing, which I think will lead right to the FVM when it lands, is actually new deal making on the Filecoin network. So we created an auction system that has stored over 150 terabytes to date on the Filecoin network. This is a simple protocol that makes it so that storage providers can bid for access to storage deals. We launched this in August, and we are now processing anywhere from 5 to 6 terabytes a day. This gets a lot easier when we have the FVM, and we can actually decentralize some of the pieces that we've just stood up to experiment with. But for this is really exciting. It's moving towards that idea of exchange and movement of data between peers on the network. And we're trying to tune this for DAOs and communities. So one of the projects that we're working with and we're really excited to collaborate with is called Absentia. And so you should definitely check out their work to try to mobilize data from the scientific community into these decentralized networks in a way that nobody can ever censor it, remove it, block it, and it really becomes a collaborative asset in the scientific community, a new form of data silo, a data silo that is open, all of the community can access, and potentially it's forkable. So we can imagine multiple lives for that data asset going forward. That's so exciting to me. We've also built a bridge to this network. So permissionless, fast, and interoperable bridge called Storage. So if you go to Storage, you can take a look at this. And this is meant to bring storage to some of the biggest Web3 communities that are out there. So developers on Ethereum, developers on Polygon, developers on Near, et cetera. And they're able to leverage storage on Filecoin, plus the interoperability of IPFS directly from their native chains. And I want to give a shout out to the miners that are working with us. So if you are one of the miners that's already working with us, you've been awesome. You're helping us build this, tap into this network of decentralized storage providers on Filecoin. But so we built a tool so that miners can actually help us move data across the network faster. So they run a simple node next to the Filecoin mining operation called BidBot. If you are a miner and you're watching this, or a Filecoin storage provider and you're watching this, definitely check out that repo. It's super easy to set up. You set it up and it gives you access to this auction stream, and you immediately start storing data from the feed. And this actually will help us grow throughput, and it helps us ensure that our users have this globally distributed, ever-growing hard drive. And that's backed by Filecoin's cryptographic storage proofs. Another really interesting thing that we'll be doing here, if you're a storage provider watching, is we're going to have a competition next month to see who can offer some of the best services for storage on the Filecoin network. And so we'll have more details about that the coming week. All of this leads to an idea of a layer 2 for Filecoin, a layer 2 that really tailors storage for communities and focuses on this high throughput data storage, access, sharing, and forking, curation on top of Filecoin. And there's a lot of work that we've been doing to experiment with what this could look like, what are the pieces necessary, and what are the specific features that communities need to store and preserve their data to really encourage this exchange of information. So where is this going? Like I already said, community-owned, decentralized, forkable data silos for humanity. Silos are a key insight, I think, here, because the ability for community to run these silos will be directly tied to their value to capture, or their ability to capture value from them. Recall, data has gravity. So if we just imagine a future where we break up data, so all of us as individuals own it and move it around, we actually lack the total value that we can create as a society by putting that information together. And if we put this information together in a way that the community owns and is forkable, that can also build gravity. So data itself will encourage the growth of more data, of more information, of more sharing. Data network effects for communities not closed by an organization. And And so we're really excited about this vision, and we'll be pushing it hard on Filecoin. We're excited to take Carl's vision for where humanity goes all the way to the next letter and beyond. So that's what I have to share about bridges today. But thanks. A high throughput storage protocol for communities is in the works. If you want to join us, check out our Discord or shoot me an email. And thanks very much to Filecoin for putting this on.